So today we're going to continue our study of ellipses, and this time we're going to learn how we can shift an ellipse so that it's centered around any point that we choose. If you watch the video on circles, then this part is going to be very familiar. So if we want to shift a graph horizontally a couple of units, what we do is we take the x out and we replace it with x minus something. If we want to shift the graph vertically a couple of units, we take the y out and replace it with y minus something. That would be a shift in the positive direction. So if we wanted to shift something up, we take y out and replace it with y minus something. And if we wanted to shift it down, we would replace it with y plus something, because that's y minus a negative number. Therefore, the general equation for an ellipse used to be just x squared over a squared. Now it's x minus something squared and y minus something squared. So that's a really important formula to use and to memorize. We'll use it a couple times in some of our examples. Let's see one. So here we want to draw an ellipse that's centered around, well, I don't know where it's centered. We're going to figure that out. Draw this ellipse. So also figure out where its focus points are. So how should we do that? Well, I recommend similar steps to what we did with drawing a circle earlier. We ought to first figure out what the center is. And to do that, we'll look at this part and see what does it take to make that a 0. Once you know where the center is, then we'll figure out what both of the radii are. Those are the denominators. Remember, that's this horizontal radius squared. And once we know where those are, we could draw the ellipse. And so let's see that in action. First thing I'm going to notice is that x minus 2, if x was a 2, that would make this a 0. And y, if y was a negative 5, that would make this a 0. And so that means the center of our ellipse is going to be 2 for x and negative 5 for y. And so that puts us about down here. Now let's figure out what the horizontal and vertical radii are. And so to do that, I'm going to look at this part. This is a squared. And so if 36 is a squared, that means a is 6. And so we need to horizontally go out 6 from our center. And so here's 1, 2, 3, 4. Let's see, that puts us at 8, right? 2 plus 6 is 8. And if we go in the other direction, 2 minus 6 would put us over here at negative 4. If we think vertically, again, b squared here is 9. And so we would find the vertical ups and outs, radii, I suppose is the word I'm looking for. We're going to go up and down 3. And so 1, 2, 3 puts us at here. And if I go down 3, 1, 2, 3 puts us at about here, negative 8. So now I can draw that ellipse by simply going out to each of those and up until we reach those points. So I can see from this ellipse that it is longer than it is tall. And so I have a little bit of an idea where the focus points are. They're going to be left and right, a certain number, but I'm not sure how far out. And so to find how far out, we need the focal length equation. We saw this in the last video. So to find the focal length, we take a squared and b squared, in this case 36 and 9, and we subtract them, and that's c squared. And so this is the formula we'll be using to find that. A squared minus b squared equals c squared. We'll put in some numbers here. A squared is the 36. B squared is 9. And when I subtract those, 36 minus 9 is 27, I think. And so if we take the square root of 27, we get that c is approximately 5.2. And so now I can draw out where the focus points are. So let's make a little tiny dot here. And to find them, we have to take the center and go left or right 5.2 units from there. So 1, 2, 3, 4, 5.2 puts us almost to the edge. And if we go in the opposite direction, 1, 2, 3, 4, 5.2, that puts us at about here. So there is an example. Here's a second example. I would encourage you to pause the video and see if you can draw it by yourself. There are a few tricks here, but I'll give you a chance to do that in a moment. So if I wanted to draw this, the most interesting trick, I think, is that the x here doesn't have something subtracted from it. That means horizontally it hasn't been shifted. It's still centered around 0. Vertically, however, it's been shifted up 3 units. And so here's the new center. And the radius horizontally is 2. And so from this point, I'll go out 2 units. That puts us at about here. And going backwards 2 units is here. To go vertically, I'm going to have to go up square root of 64. That would be 8 units up. And so 3 plus 8 puts us at 11. And if I go down 8, 3 more, 5, I think that brings us to negative 5. And so our ellipse here is going to go from there to there and here to here. And so there's our ellipse. This time it's definitely taller than it is wide. And so I can tell you that the focus points are definitely up or down from the center. And so to find that, we need to use a squared minus b squared equals c squared. Or in this case, b squared minus a squared equals c squared, because the b squared value is bigger. So b squared was the 64, a squared was 4, and so if I subtract those, I get 60. And so c is the square root of 60, and don't know that one. Let's see here. Square root of 60 is about 7.7. So let's draw some focus points that are 7 by 7. Not sure if you can hear that, but that would be my little daughter, Penelope, screaming upstairs. And so I'll have to go check on her in a little bit, although Mom's here. So I'm not leaving her alone. Don't think I'm a neglectful parent here. Let's see. Up 7.7 would put us here, and down puts us at about here. All right, I'm back. Sorry about that. Mom wouldn't let Penny hit the kitty with a book, and so that made her yell and scream. So anyway, here is another problem, and hopefully this one won't make us yell and scream. This time we're going to try to write an equation for an ellipse. And so to do that, let me pull out a formula. So this is our same template as before, but this time there's 2 additional blanks here for horizontal shifts and vertical shifts. And so let's see what we got here. We need to write an equation for an ellipse with vertices at certain spots, and some of them are blank. All right. Well, let me just make a quick little grid and plot a few of these points. So 10, 20. Let's see, that would be over 10 and up 20, like here-ish maybe. And then 36, 20. So that's over a lot and up 20. And then I've got something 15 and something 25. I'm guessing something 15 is going to be down here somewhere, and something 25 is up here somewhere. And so what I really need to do is find the vertex, or the center. So the center is going to be in the middle of this, and specifically it's the midpoint of our first 2 points that we drew here, 10, 20 and 36, 20. So I know it's going to have a y-coordinate of 20, and the midpoint between 10 and 36, 10 and 36 are, what is that, 26 apart, and so that would mean that half of that is 13, and so if I take 10 and add 13 to it, that should put us at 23, 20. So there's our center, 23, 20. Is that right? 10 plus 13 is 23, plus 13 is 36. Okay, yeah. So we can write our equation now, or at least most of it. So we know that horizontally this was shifted 23 units over, so I'm going to write x minus 23. And vertically this was shifted 20 units up, and so I'll write y minus 20. Then we got to figure out what the horizontal and vertical radiuses are. And so the horizontal radius we found earlier, that was the 13 that we had said. And so I can put 13 squared in here. I guess I have to make that a little smaller, huh? There we go. And vertically, well, here we knew that this was a height of 15 and this was a height of 25. And so 15 up 5 gives us to 20, and up another 5 gives us to 25. And so we must have a radius of 5 vertically. So there's our equation. If we want to find the focus points of this, I can tell you already they're going to be at the same height as the center, so it'll be something 20, but they're going to be out some ways because it's longer than it is tall. How far out? We need the focal length formula, which is a squared minus b squared equals c squared. And so if we put in some numbers here, 13 squared is 169. And then 5 squared is 25. And so if we subtract those, 169 minus 25 is exactly 144. And that's convenient because 144 has a nice square root of 12. And so our focal length is 12. And what that means then is that our focus points, let me make that pink a moment. Our focus points are then 12 units left and right from the center here. And so 12 units out puts us at about here, and 12 units this way puts us here. And so if we wanted to actually put coordinates for the points here, the height of each of those points is something 20. And let's see, 23 plus 12 brings us to 35. So that's that one. And this point over here would be same height, 20, but it is 12 units less than 23. So that's 11, I think. No, 14. I don't know. I can't do subtraction. Let's try one more time. Let's see. This is, yeah, I was right the first time. 11. Okay, there's the focus points. One last example. What if we wanted to write an equation and we have a specific goal in mind for where we want the focus points to be? How can we make that happen? So let's make a quick sketch of this. So I want a focus at 4, 7, and so that would be out 4 and up 7, so maybe about here. And I want another focal point at 4, 9. Therefore, the center would be exactly halfway between them. And while I'm on it, let's think about the coordinates of that. It would definitely have an x-coordinate of 4, and halfway between 7 and 9 would be 8. So there's our center. So we can actually write quite a bit of our equation right now. We know that it's centered at 4, 8. And now we need to figure out about how tall this is and how wide this is. And so I do know that it's taller than it is wide because the focal lengths are vertical from our center. They also told us that the two other points, it has to go through 4, 6, and it has to go through 4, 10. And so those are 2 units up and down from our center. So that means vertically our radius is 2. So I can put a 2 there. What I need to know is how wide is this ellipse? And in order to figure out how wide this ellipse is, I'm going to have to use the focal length formula. So the focal length formula, remember, is a squared minus b squared equals c squared. Or in this case, we're going to have to use b squared minus a squared equals c squared. The reason I know that is because the b squared has to be the bigger of the two values because I know it's taller than it is wide. So let's pull out that formula, and then we'll start putting in things we know. We know b squared is 2 squared, and we know that c squared, the focal length, has to be 1. And so we can fill in the b and the c, but we don't know a. And so take a couple moves to solve this. 2 times 2 is 4, and 1 times 1 is 1. And so we've got 4 minus a squared equals 1. And if we subtract 4 from both sides, hold on a second, I'm going to disappear. Whoop. There we go. That gives us a squared equals negative 3. And dividing both sides by negative 1 and taking the square root, we get that a has to be about 1.7. So if I wanted to draw this, I'm going to have to go 1.7 out in both directions. Now I can draw this ellipse. Right, up to there, down to there, out, and out. So there's our ellipse. And if we wanted to complete our formula up here, we could write 1.7 squared, but actually we figured out that a squared is exactly 3. And so I think what would be a little cleaner would be to write this as just a 3, but not 3 squared. And I can't fix that easily, so maybe we'll go back to the 1.7 squared. Gotta love making videos on the fly, huh? So anyhow, there's a few examples of working with ellipses. And so I hope that you learned something. If you have a question, feel free to put it in the comments or message me, and I'll get back to you. Thanks for watching.